In today's lesson, we're going to learn how to simplify complex fractions. A complex fraction is a fraction in which the numerator and denominator both, or maybe one of them, contains fractions. To simplify complex fractions, we're going to rewrite it as a single fraction with no fractions in numerator or denominator. So what we're going to do, we're going to treat it like a division problem, dividing both rational equations. So we're going to set up the division problem, and then we're going to multiply by the reciprocal and simplify and factor if necessary. So if you notice in the first example, we have two fractions divided. So the main division is going to be right here. So we have a over 2 divided by a squared over 4. We're going to rewrite it as a division. So we have a over 2 divided by a squared over 4. Now we're going to change this into multiplication problem. So we're going to multiply a over 2 by the reciprocal of the second fraction. And then we're going to simplify anything that's necessary. If you want, you can combine them together, so that will give you 4a over 2a squared, which 4 and 2, they're both simplified to 2, and a divided by a squared is just 1 over a, so we have the final answer is going to be 2 over a. Okay, in the second fraction, the division is right here in the middle. So the fraction in the numerator is 6 over xy. The fraction in the denominator is 3y over 8x cubed. So we're going to take the fraction in the numerator and multiply by the reciprocal of the fraction of the denominator. And then we can reduce or multiply before reducing. It's completely up to your personal preference. I like to simplify before I multiply, so I'm going to simplify 6 and 3, so that's 2 and 1. And then I'm going to multiply everything else, which will give me 2 times 8 will be 16 x cubed over xy times 1y is going to be xy squared. And as the final answer, I'm going to simplify my variables. So I'm going to divide x cubed by x by subtracting exponents, which will give me 16x squared over y. And this is my answer. Okay, let's look at the next two examples. Sometimes your fractions are going to be more complicated rational expressions. Still, the first thing you want to do, you want to identify where is the main division, where is the actual, the big fraction. And it's good to kind of like maybe bold that. So this is your really division, right in the middle. So my fraction in the numerator is k minus 1 over k, and I'm going to multiply this fraction by the reciprocal of the fraction in the denominator, so k squared over k squared minus 1. And that becomes simplifying two rational expressions. So we need to factor anything that can be factored. Going back to the lesson that we did a few lessons ago. So if you examine the first fraction, there's nothing to factor in numerator or denominator. But if you look at the second fraction, the denominator is the difference of two squares. And then I can reduce anything that I need to reduce before I multiply. So k minus 1 cancels, and then k and k squared will cancel, leaving it as k over k plus 1. And that's my final answer. Okay, the next example, we are dividing 7c plus 35 over c by c plus 5 over c squared. So my division runs right here. So we take the first fraction and we multiply by the reciprocal of the second fraction. And now we're going to factor and simplify before we multiply. So if you notice in the first fraction, we can factor out 7 from a numerator. And there is nothing to factor in the second fraction, so I'm going to just rewrite it. And then we're going to simplify anything that we can. So c plus 5 cancels with c plus 5, and then c with c squared, which will leave only one c in the second fraction. So my final answer is going to be just 7c. Okay, the next two problems I would like you to try on your own. And when you are ready, you can play this video. So please pause, try to do the next two problems on your own, and then unpause to check if you did it right. Alright. If you notice, this actual complex fraction has a fraction in the numerator, but there's no fraction in the denominator. But you can easily create a fraction in the denominator by writing it over 1. And then you're going to multiply the first fraction by the reciprocal of the second fraction. Then factor anything that can be factored. So we have a common factor of 15. And then we have a common factor of 12 in the second fraction. Now it's time to reduce anything that can be reduced. Notice that 1 minus r and r minus 1, it really isn't the same. They're opposites. So to make the expression the same, we can factor out negative 1 from the first fraction. So we're going to get negative 15 r minus 1 over 15 r squared times 1 over 12 r minus 1. Now we can cancel out r minus 1. We can cancel out 15s. And what's left is my answer. So I have negative 1 times 1 in numerator and only 12 in the denominator. And that's my final answer. So now let's look at the last example. If x is greater than 3, which of the following is equivalent? X greater than 3 means that all of the x values has to be greater than 3. That has nothing to do with our simplification that needs to be done in this fraction. So here the main division runs right here. So I have 1 divided by 1 over x plus 2 plus 1 over x plus 3. So the first step we want to do, we want to add the fractions in the denominator. So we're going to, on the side, we're going to add rational expressions by figuring out the common denominator. And the common denominator is going to be x plus 2 times x plus 3. Which means I need to multiply the first fraction by the missing factor of x plus 3 and the second fraction by the factor of x plus 2. So that will give me 1 times x plus 3 plus 1 times x plus 2. Then we're going to combine like terms in numerator. So I'm going to have 2x plus 5 over x plus 2 and x plus 3. So just to save the space, I'm going to erase my denominator, and I'm going to multiply x plus 2 times x plus 3, because if I look at my answer choices, all of them are distributed. So I'm going to take this out, and I'm going to multiply x plus 2 times x plus 3 by FOILing, by distributive property. So x squared plus 3x plus 2x plus 6. So my expression is 2x plus 5 over x squared plus 5x plus 6. But if you notice, the original problem was actually 1 over 2x plus 5 over x squared plus 5x plus 6. So now I have to go back and actually rewrite it as my original layout. And if I have 1 over anything, it means I have to take the reciprocal. So the answer for this question is B. It's the reciprocal of 2x plus 5 over x squared plus 5x plus 6.